Hi, it's Dr. Weideman again. We're in Chapter 21 now, and we're going to work a problem from our ebook. We're going to use problem 27 on page 605 in your ebook. So let's take a look at the problem. And here it is over here. When you first, actually this was first introduced in the prior chapter, but a company institutes an exercise break for its workers to see if it will improve job satisfaction, as measured by a questionnaire that assesses the workers' satisfaction. Scores for 10 randomly selected workers before and after the implementation of the program are shown in the table below and also in the StatCrunch dataset. Identify the procedure you'll use to assess the effectiveness and check to see if the conditions allow for that. Conduct an appropriate hypothesis, state in your conclusion. So first of all, the two samples are definitely paired because we have the same worker before and after. So we know that we can use the methods from this chapter for pair of data, and we're going to use an alpha of 0.5. So we're going to define the difference mu sub d. We're going to go after minus before, because by doing that, if the satisfaction went up, I'm going to get positive numbers. So my null is going to be that the difference is 0 versus the difference being greater than 0. Then I need my assumptions and conditions. I have random independent. They said they were randomly selected. Yeah, they were randomly selected, so they should be independent. The data are definitely paired. It's the same worker. Less than 10%, we have 10 workers. And then the nearly normal condition we need to check in StatCrunch. So the thing I don't see here is the differences. So you could actually calculate these manually, but you can also do what's called create an expression, so it'll do the work for you. So if you click on that option, and we're going to type in what we wanted to do. So we wanted to take the, no, actually we're going to do the after minus the before, and then just say OK, and it's going to go ahead and it's going to add that into the column right over there. So it was added right here. So these are my differences. So I need to do a histogram of that column to see whether or not I meet that nearly normal condition. So I'm going to take that after minus before, compute. I see a little bit of a gap here. Let's see what our difference is. Let's go ahead and edit and maybe change the bit width a little bit, maybe go up to 7. Yeah, I don't think it's really terrible. It's a small sample, but I think we're good to go. So we want to conduct that hypothesis test. So what do? We go to stat. We're going to go t-stats, and we can use paired because we actually have the data right here. And we're going to take the after and then the before. And our hypothesis was we wanted this to be greater than 0, remember, because we wanted the workers to be more satisfied after the exercise break was instituted. So what do we get? We get a t-statistic of more than 3, 3.6. The p-value is very, very small, so therefore we would reject the null and say that the exercise break is seeming to have a good impact on the satisfaction of the workers. We can also go ahead and do the confidence interval and see what that looks like. And so the confidence interval goes from about 3.2 up to 13.8. So we're 95% confident that the mean difference or the improvement in the worker satisfaction after the exercise program was between 3.2 and 13.8 points higher. So that's a pretty good effect of that exercise program.